Ever wondered how 3D models of real-world scenes are created from just a bunch of 2D photos? It's like turning a flat painting into a 3D sculpture, except the tools are math and AI. Today, we're diving into a breakthrough technique called iLRM, that's revolutionizing 3D reconstruction. This isn't just faster or smarter, it's fundamentally rewriting the rules of how we turn flat images into immersive digital worlds. Let's start with the problem. Traditional methods for building 3D models from photos are like trying to solve a puzzle by staring at every single piece at once. They process every pixel from every image, which is super slow and uses way too much computing power. Imagine building a house by counting every brick in a photo. Tedious, right? That's why most 3D models today rely on 3D Gaussian splatting, a technique that creates point clouds with smooth textures, but it's stuck in the past. Here's the issue. Gaussian splatting forces you to downsample images, like squishing a high-res photo into a lower resolution. The result? Blurry details or way more data to process. It's like trying to build a skyscraper with a toy wrench. Either you compromise on quality or you're stuck with a ton of work. But what if you could keep your high-res images and control how detailed your 3D model is? That's exactly what iLRM does. Enter iLRM, a model that's rewriting the rules. Instead of brute forcing through all the data, it uses an iterative refinement process. Think of it like sketching a portrait. You start with a rough outline, then gradually add details like eyes, hair, and shadows. iLRM does the same with 3D scenes, improving accuracy step by step without getting bogged down by unnecessary pixels. Here's how it works. 1. Decoupling scenes from images. Instead of tying the 3D model directly to the input photos, iLRM creates a separate representation that's more compact. It's like using a blueprint, instead of copying every brick from a building's photo. 2. Efficient attention mechanisms. Traditional methods process all image data at once, but iLRM splits the work into 2 stages. First, it focuses on individual photos, then connects them globally, like checking each puzzle piece before fitting them together. 3. High-res guidance at every step. Even though it simplifies the process, iLRM still uses high-resolution details from the original images to ensure the final model is sharp and realistic. The results? On standard test datasets, iLRM outperforms existing methods by a huge margin. It's faster, uses less memory, and handles more input views, like 8 photos instead of 2, without slowing down. For example, one test showed a 3 decibel improvement in image quality, while cutting processing time in half. But here's the real win. iLRM decouples image resolution from the number of Gaussians. So you're not stuck choosing between sharpness and efficiency anymore. It's like giving your 3D model a super zoom lens, crisp details where you need them, but lighter and faster where you don't. The team tested this approach against old techniques, keeping the same number of Gaussians. While other methods had to lower both image quality and the number of viewpoints, iLRM kept high-res images, but used a smarter way to generate fewer Gaussians. The result? Better visuals, faster processing, and less memory use. And the hardware? They ran it on a single RTX 4090, a GPU you can buy at your local store, while others needed the super powerful H100. It's like comparing a sprinter to a marathon runner. Both get the job done, but one uses way less fuel. But this isn't just about speed, it's about smarter design. By rethinking old constraints, the team unlocked flexibility that could reshape everything from VR to self-driving cars. Imagine scanning a historical site with a drone and instantly generating a detailed 3D model for virtual tour. Or creating lifelike avatars from just a few selfies. This tech is paving the way for smarter, faster 3D reconstruction, turning flat photos into immersive digital worlds. Next time you see a 3D model, remember, it's not just pixels. It's a symphony of math, attention, and a little bit of digital magic. Thanks for watching. Hit subscribe for more deep dives into the science behind the tech.